catfish. I now request the speaker to begin. Thank you.
Thank you. Thank you for your introduction. So I think I need to share my screen. So is it visible now?
Yeah, it is visible. You can put this in presentation mode, slideshow mode.
Yeah. Okay. Thank you. So I'm Dr. Rameez Roshan. I'm currently working as an assistant professor at the Department of Aquaculture in the Kerala University for Fisheries and Ocean Studies. So today's topic is business opportunities in magur catfish. So uh, I'll first start with an introduction to magur, and then we will see what is the importance and why, actually, in fact, we should look into the magur. What are its advantages and what are its weaknesses, and some of the technical aspects of the seed production, its grow out, and maybe some diseases. And finally, we will look into the economics of the magur culture and wind it up. So, as you may be aware, the Clarius magur, which is an endemic species to India, in fact, the same species before 2012 was known to be as Clarius batrachus, or maybe they were not strictly the Indian catfish was not called as Clarius magur, but a study by NBFGR found that Clarius magur is
Dr. Rameez, we lost your voice. Hello, Dr. Rameez.
and sorry, spectral spines, and
Your
they have
presentation
the.
is not visible.
Is it? It's not visible.
Mm.
No, I'm presenting it.
No,
Oh,
you can stop and restart.
maybe share screen and window. Yeah, was it visible previously? Okay, now is it visible?
Yeah.
Okay. Yeah. So, so they have the ability to breathe outside water, and the distribution of magur is mainly concentrated in the northeastern states. Then the state of West Bengal, Assam, Tripura, Bihar, and culture practices are also being practiced in Andhra Pradesh. So why we are behind this aquaculture diversification? As you may be aware, the Indian aquaculture, the most of the production in the Indian aquaculture is from the Indian major crops, as well as some minor crops and pangasius. So we know the aquaculture industry has seen a bandwagon effect with regard to monodon and venami, which leads to many ill consequences. And from the business point of view, the basic rule is do not put all your eggs in the same basket. And also the farmers follow something called the cobweb rule, which means that they decide, from the aquaculture point of view, they decide the stocking based on the previous year's prices. And this led to a glut in excess in the market and less remunerations as supply exceeds the demand. So in this case, the diversification of the species means including more number of species into aquaculture can counter some of these issues and minimizes our chances of incurring losses. So identifying the potential species for the aquaculture diversification is a need of the hour. And the magur is considered as one of the potential species for aquaculture diversification in India. There are many strengths when it comes to magur, or many advantages, because magur is since it's the bottom dwelling species, it is very much suitable for the polyculture, especially with IMCs. So the farmers who are already doing the IMC culture can practice the polyculture of magur, which gives them a more remuneration. And it is well established that it has got a very good taste, and it is excellent in its nutritional profile. There are already there are many publications on these aspects. And the magur is they can adapt to a wide range of the climatic conditions, from muddy waters to the clean fresh waters they can inhabit. And as the water quality, especially the DO, they can survive in the very low DO conditions. And when it comes to the culture practice, one of the important thing is that the magur can mature in pond conditions, and the controlled reproduction is possible. So in order for a seed production to achieve, it is very important to have a controlled reproduction and to close the cycle. Generally, magur is considered to be a hardy species, even though it has a lot of disease problems. So always hardy doesn't mean that no diseases affects these particular species, but it just means that it can survive. It can survive in very harsh conditions, in the sense low DO. Okay, so as strengths, there are weaknesses. The one of the major problem in magur aquaculture, which hinders magur aquaculture in India, is the availability of low quality seeds. The current practice include the collection of the seed from the wild, which puts a lot of pressure on the in the wild stocks. And especially this species has a very low fecundity. I mean, theoretically, they say it is almost around 20,000, but practically, it's around somewhere around 5,000 to 10,000. It's highly variable, maybe up to 15,000. So on average, we can say maybe 7 to 10,000 is the fecundity. And for the reproduction, even though we controlled reproduction is possible, the collection of milt is pretty much difficult, because stripping the male, in contrast to the IMCs, where the male could be stripped, for example, rohu and katla, the male can be stripped and milt could be collected. In this particular species, the milt cannot be collected by stripping. The male has to be sacrificed. The testes need to be taken out and macerated, and have to produce a sperm suspension. And also, there is one of the issue, even though the Clarius gariepinus African catfish is banned in India, still we suspect that there are already hybrids existing between the Clarius gariepinus and than this particular species. It is very also it is difficult to identify or differentiate between this hybrid of hybrid magur and the wild variety of magur. But some institutes, research institutes, are working on to identify some markers which are specific to hybrids in order to differentiate them at the molecular level.
Dr. Rameez, sorry to interrupt. Your presentation is gone again.
Oh, sorry. Let me. I don't know what is happening. I'll share once again. Yeah. So please stop me if the presentation goes. Okay. Thank you. So yes, so these are the weaknesses in magur. In fact, there are maybe more weaknesses than the strength, but we need to come out with alternate ways to address these weaknesses. So if you want to go ahead and augment the production and improve the farmers' income in the aquaculture field, so in the in Indian aquaculture, and let's see about the broodstock management, the aspects of broodstock management in magur. So currently, the broodstocks they are collected from the wild, maybe when they're around 50 to 100 grams, and the practice is to collect it from the wild and keep it for a quarantine of maybe for 2 weeks to see for any possible diseases or deformalities. And the magur, the brooders had to be feed with any commercial feed with 30 to 35% of the protein in order for the development of the gonads. And either they can be maintained in an earthen pond, and if earthen ponds are not available, it can also be maintained in the cement tanks with a soil base. And the optimum the water quality is very important. As you know, in any stage of the aquaculture, water quality is very important. So at least an exchange of 20 to 30% of water at fortnight intervals is essential for the broodstock management. So once a broodstock are matured, it should be selected for breeding, for reproduction. So the magur breed between June to August. Sometimes it may extend till September or maybe even to the November. And the mature magur weighs around 100 to 150 grams. On an average, maybe 130 to 150 grams. Even it reaches 200 grams. Some animals. And how to identify the males and females, as you can see in the picture, the males have an elongated and pointed genital papilla, whereas females have a round and button-shaped genital papilla. And how to see also the females when they are ready, when they are gravid, I mean their belly usually seems to be swollen, and with the insertion of a small catheter you can take out some of the eggs and see if the eggs, what is the present stage of the egg, and take a small microscope and if you measure the diameter, 1.2 to 1.4 millimeter diameter is a suitable egg size for reproduction. But generally we don't do that. If you just give a little pressure on the belly, and if eggs are oozing out, that means the magur female is mature enough to be reproduced. So
Dr. Rameez, you need to change the slides. Pictures are not visible. The weaknesses slide is visible now.
which is that?
A weaknesses slide is visible now.
Oh my god, I don't know what is happening. So which slide is visible now?
Now the induced breeding.
So can you see the induced breeding? So I think the problem is that when I go to the presentation mode, it may not be visible.
Now it is
Can
visible.
I do it like this? Is the picture visible?
Yeah.
Okay, so I think this
You
would
can
be.
just zoom it little.
Yes. Okay.
Yeah.
Maybe I can add this. Is it okay now?
Yeah.
Yeah. So, so in order to breed, the current protocol for induced breeding is using any of the commercially available inducing agent or synthetic hormones. So usually ovatide is used for the as an inducing agent. So ovatide or any synthetic hormone is injected to both the males as well as the females. And as you can see in the picture, the injection is given intramuscularly, and the males are injected, the females are injected
Dr. Ramesh, your presentation is gone again. Hello, Dr. Ramesh.
once the inducing agents are
Dr.
injected.
Ramesh.
Yes, again, shall I?
Sorry to interrupt again. Your presentation is gone. Maybe you can just log off and re-log in.
I don't think it is going to help, because since the problem could be that I've logged in from the browser. So
Okay.
maybe I can share it again. It's okay. Whenever it goes off, please kindly let me know that, then so that I can share it back. Okay. Yeah, now I think it's visible.
Yeah.
Yeah. So once the inducing agents are injected, the males and females that can be separately kept in the tubs or in the tanks, and the females, after about 16 to 17 hours, the eggs can be collected from the females, as you can see in the bottom picture, by the stripping of the females. But as I told you, it is not possible to collect a milk directly from the males, so we have to make a sperm suspension. In order to make a sperm suspension, first, following the protocols, the animal ethics protocol, you have to anesthetize a male. So the clove oil will be, small concentration of clove oil will do the anesthetization, maybe 2 ppm, 2 parts per million of clove oil. Maybe you can take 1 liter or 5 liters of the water and add some clove oil and put the males. And once it is anesthetized, you can take it out and make a small incision or on the belly. And in the next slide we'll see how to do that. And usually the 2 females are fertilized with 1 male in order to maintain the 1 male is enough to fertilize 2 females, and mostly it is the case with all the aquaculture species. But this is a very standard mating design. So this is how the milk is collected and sperm suspension is made. As you can see in the first picture, there is a small incision made in the belly, and this testis, which is milky white in color, means that there is enough milk in that. They're taken out and they are macerated in normal saline solution, which is 0.9% NaCl solution, and they are being macerated in a mortar with a pestle. And after this particular suspension is made, you can use these. You can transfer the suspension into the eggs, or into the tray where the eggs are already collected, and they can be washed thoroughly with running water. They need to be washed thoroughly with running water at least twice or thrice, and then the fertilization happens, and they can be transferred to the flow through incubation units for the further this one. So this is how the first slide shows that the milt is being used to first picture shows of milt is being used to fertilize the eggs, and they can be transferred to the flow through systems. Flow through system need not be very big. The small tubs can be used with small arrangements, and usually some hard substrate is used because they are sticky eggs, and these eggs for proper aeration, and also this picture which shows that golden color, they are actually fertilized eggs, and which are not fertilized will be visible as opaque in color. And so the unfertilized eggs detaches from this hard substrate. In this case, an icornia is used for attaching these eggs, fertilized eggs. So it is easy to collect the fertilized eggs, since the unfertilized eggs get automatically detached from these icornia roots. All right. So this is some of the optimal water quality parameters required for fry reining. Sorry, this is given as Batrachus, but it's magur. That is not Clarius batrachus. It should be Clarius magur. So water temperature, dissolved oxygen, carbon dioxide, pH, alkalinity, hardness, ammonia nitrate, all these things to be taken care of. So a normal freshwater will do all those things. You don't have to worry. Otherwise, if you doubt any of the water quality, you need to check for the water quality parameters. For larval feed, once after 24, maybe after fertilization, within 24 hours, the hatchlings comes out. The eggs hatches, and once they are hatched, it will take another 4 days for the yolk sac to be completely absorbed. And after yolk sac absorption, the larvae need to be fed ad libitum. Ad libitum means till it eats, or you give the feed until it feeds. That's ad libitum. And can be fed ad libitum with zooplankton such as copepod, Daphnia, Moenia, Artemia, Noclea, Romulus can need 2 there is a very higher chance for the larvae to be susceptible for the diseases. So it is very, very important to keep the water quality levels at the optimum level. Some of the diseases which are reported are skin flu and ulcerative diseases, Aeromonas bacterial disease, and fungal infection. I think Aeromonas disease is very, very common, and once it starts, then just all the fry or all the larvae dies maybe within a week. So it is very important to monitor them routinely during the larval rearing.
Your
And
presentation is not visible, Dr. Rameez.
yes. I'll just share that again. Yes. So next is fry to fingerling rearing. Once maybe after 8 to 10 days, this can be removed from the this flow through tubs and can be transferred to an outdoor tanks, or maybe small other because optimum size for stocking at the grow out pond or the earthen ponds could be maybe around 5 to 10 grams maybe. So it is important to have rearing phase where it is reared from fry to fingerlings. The magur fry can be stocked. The stocking density, you should be careful about the stocking density. It should be around 150 200 per meter square. So if you're depending upon your area of the cement tank. You can multiply it and stock in those particular cement tanks. And the fry, they are usually fed with the 6 to 8% of the body weight twice and thrice a day with maybe artemia. That would be the better feed, but it's costly. Otherwise, you can make this rich in zooplanktons and phytoplankton, so need to be not to give external feeds much. And the fry reach about 3 to 5 grams in 3 months, maybe not 3 to 5 grams, maybe at least 10 grams, I would say, in 3 months, which is the ideal size to stock in the grow out culture ponds. So in the grow out culture pond, usually the magur can be stocked at a very high, stocking density, maybe 50,000, 70,000 per hectare. But again, this is a standard textbook numbers. But practically, when we do, we can at least stock at density of 2 per meter square. That means a hectare is around 10,000 meters square. So it's like that is optimum one, but this is towards very higher side. So if it is a polyculture is practice, maybe we cannot use this high stock intensity. And so there are reports, there are studies which shows that there is no difference in the growth when the magur is reared in polyculture and monoculture systems. So it is always better to go with the polyculture system, because this is going to be an add-on to the remuneration. And usually also there are reports which says that, studies which says that if you stock at a higher body weight like 10 grams, there is a higher chance for growth and survivability. The major issue with the magur larval rearing is it's only 20% of the larvae survives after till the fry or fingerling stage. And still again, almost 80% survival is towards a very higher side. We cannot expect more than 60 to 70% of survival. And still the species is called a hardy species. So anyways, these are the water qualities. Again, it is very, very important whenever the magur is cultured in a confined environment, like cement tanks, is very, very important to keep the water qualities on check. This can be obtained from the standard literatures. So there are in the grow out also, there are number of diseases being reported, and the symptoms are also listed here, and there are control measures. But it is very important to usually there are some, in some cases the antibiotics are written, but it's not a good practice anyway. So the prevention is better than cure. So the most one of the issues which causes the disease is the mismanagement of the water quality parameters. So if you always keep a check on water quality parameters, the immunity, it can sustain the immune level of the fish, and it may be less susceptible to the diseases. And the production harvesting magur attains a marketable size, which is around 100 to 150 gram in a culture period of 10 to 12 months. So we can't really say that it is a very good growth, because attaining 100 to 150 gram is like a very slow growth rate. And I've mentioned that in the previous slide, that one of the weaknesses of magur is its low growth rate. So considering these issues, the ICR Institute have taken up the selective breeding programs of magur, especially ICR CIFE, and now it is in the second or third generation. And the reports, the unofficial report says that the growth rate of the magur, there is a cumulative increase in the growth rate by 20% in comparison to the base generation. So that is a very good technology. Like genetic selection programs can give a sustainable and everlasting increase in the production traits. So they may be at the preliminary stage, and only growth rate might be the only selection objective. So anyways, harvesting, the another thing is harvesting. In order to harvest, the complete dewatering of the pond is required, because magur is a bottom dwelling fish. And so the most of the times they grow to the mud, and they live at the bottom of the, and it's very difficult for one to catch the magur with a net. So they go to because of their growing nature. So complete dewatering and hand picking is required. So that makes a little bit more laborious. And Yes. So from a hectare, a production of up to 2 to 3 tons can be achieved in 10 to 12 months from the wild collected magur. Okay. So, but again, the problem is that the during the harvest, this is a kind of 100 to 150 gram is the mean weight of the magur obtained from the pond after, or maybe obtained after the culture. But since they are collected from the wild, even the range can be 50 to 200 grams, which is like a very wide range. So that is one of the problem. Again, the sizes are not uniform. When we talk about the mean weight, we don't really give emphasis to the range. So again, maybe the by adopting suitable breeding programs, we can make uniform, come out with uniform size magur. So magur seed is any even though this is a condition and due to unavailability and very good market price, the magur seed is of great demand in different part of the country. And considering that few hatcheries are established in private as well as the government sector in Odisha, West Bengal, Bihar, Chhattisgarh, Assam, Manipur, and Tripura, usually magur seed they are sold at maybe the price early price is sold at 1 or 2 rupees, or and advanced price at 5 rupees per fry. So coming to the important last slide, looking at the economics of the magur culture per acre. This is not per hectare. So there are fixed cost per hectare and operational cost. In the fixed cost, there is some cost assigned. This is are all based on some of the data collected from the Andhra where this culture is being practiced. This is not an all data. This is the current data. So per acre, this is a cost per acre. Under current practice in the Andhra Pradesh. So for pond excavation per acre, it is around 80,000. Then biosecurity measures, maybe sometimes bird fencing or snake fencing is required for biosecurity measures. It may cost around 20,000, and motors of pumps 15,000. Some miscellaneous cost, and if you include the depreciation of fixed effects and interest on fixed effect, that will be around 47,000. The total fixed investment is 1,25,000. And the operational cost, the total operational cost comes around, the variable cost comes around 3,50,000. And adding that with the total fixed cost, uh, the gross revenue is around for 5,44,000 rupees. And from an acre, this data shows that there can have a net revenue of 1,46,000. Maybe that is an ideal condition, under ideal condition, but at least this data shows that the agriculture is profitable, and also it is in need of hour, because the price per magur as per today's price, this is I've given the 400 rupees price per kg. This is towards a minimal side. So farmers, uh, based on the personal communication, they said it could be anywhere between 400 to 600 rupees per kg. So uh, so that means the magur culture is profitable, and there is some business opportunity in magur culture, especially the some of the farmers who are already practicing the IMC culture. They can think about the magur in a polyculture system, and maybe if they want to have some controlled breeding program, they can approach some universities which give technical consultancies for the breeding programs, like some genetic selection programs or things like that. And maybe in the future there will be improved variety of magur seed or quality seeds available, both in terms of growth as well as the disease resistance. By this, I end my presentation, and I would like to thank the organizers for inviting me for this lecture, and also thank the Vice Chancellor, Kerala University of Fisheries and Ocean Studies, and the Registrar and my HOD for giving me permission to present in this session. Thank you. If any questions, they can be posted. Can I unshare this? Can I stop sharing? Hello? 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 Okay. Uh, It's all right. It's all right. No issues. If you want to end the session, you can end. And if you have issues with the network, that's okay. Can I disconnect the session?
Hello?
Yeah.
Yeah, okay. Sorry, sir.
No, it's okay. No
My
problem.
keyboard was hung.
It's all
Okay,
right. It's all right.
so thank you for this session. I will
Yeah.
take some 3 to 4 questions are there. So
Okay.
the first question is Magur a place name?
No, it's Magur is not a place name.
Okay.
Uh, yeah, it's not a place name.
So it's a fish name.
Yeah, it is a species name. I have not actually looked into why from where the etymology of the name, in fact, but it is not a place. I don't know any place, after the Magur. So I've not gone into the etymology. It's not a place name anyway. So
Okay.
maybe, yeah.
Okay. So uh, yeah. So do you help farmers, and if yes, how?
All right.
Fishery. I mean
Uh,
the farmers were selling and all. Who is doing the
selling.
fishing of this? I mean, who is doing the fishing of this fish?
I'm not per se an economist, and so we don't do or help with the sale things. But I'm a geneticist. I work mostly on the genetic improvement programs. All
Mm.
right. So how we help is we have running projects on genetic improvement programs, and we come out with improved varieties of some fish. But now the institute in which I am working is, we have the improvement programs at its initial stages because it is a long-term process, and we can give technical consultancy if there are some farmers, advanced farmers who are willing to take up the breeding. I mean, genetic breeding programs in their farms. Then we are ready to give technical consultancy at the university level.
Okay.
So that's how.
Okay.
Yes, we are a university. We are a research institute. We are not, per se the administrative part of the government. So we are not involved in selling or corporatives or things like that. We do research mostly,
Okay. Okay.
right?
And next question is, other than India, in which other countries this fish can be grown? Is grown, I mean.
That's what I said. This is an endemic species to India. All right. So this. Now we claim that this particular species is only found in India. So previously, see, there is another close related species which is known as Clarius batrachus, which is found, which is called generally called as Asian catfish, is found across India. According to the previous reports, India, Pakistan, Nepal, Myanmar, all the Southeast Asian countries. So that's why it's called an Asian catfish. But some years before, one of the research study says that genetically, Clarius magur is distinct from the batrachus found outside India. So we say that this is an endemic species to India. So it has only culture potential, and its culture practice is only per se followed in India only, because this is our the Indian species.
Okay.
Okay.
So now we have the last question. Please let us know a little about your education background and what made you to take an interest in this subject.
All right. So my education background is I finished my degree bachelor's in Bachelor of Fishery Science, which is shortly we call as BFSC. So I finished my bachelor's from Kerala. So back then, this university where I am personally working, I've studied here only. I joined in 2007 and I passed out in 2011-12. It was a four-year course, and then previously it was called College of Fisheries and Kerala Agriculture University, but this KUFOS was founded in 2010. So I joined under Kerala Agriculture University and I passed out from this particular university. And after this, I went for my master's at ICAR. There is an apex body called ICAR, Indian Council of Agriculture Research, which has 4 deemed universities. One is dedicated for agriculture, which is IARI in New Delhi, another for veterinary, another for dairy, another for fisheries. And the fisheries deemed university is at Mumbai. So it is called ICR Central Institute of Fisheries Education. I finished my master's in fish genetics and breeding, and so I worked in some during the master's program. We have 1 year dissertation, a small thesis, where I worked in the population genetics of this particular species, Clarius magur. Then afterwards, in 2015, 15, I joined for my PhD, which again I did in this particular species, but specialized in something called quantitative genetics, where I did the selective breeding programs and things like that. So my PhD was awarded in 2021. I have some experience working in some other research projects, and then this year I joined as an assistant professor, permanent faculty at KUFOS. So what made me interested to join to the fisheries is that, in fact, I came by default, but then once I did my bachelor's, I found some interest, and since then I came to know about the opportunities, like for research and other things. Especially I was from my childhood, I mean from my school days, I was really interested in genetics. So when I understood that, okay, there is opportunity that I could specialize in genetics, and it's almost like a virgin area, at least in Indian aquaculture system, and genetics was adopted very lately in the fisheries. Maybe Norway is the first country to adopt the genetic breeding programs in 1970s in salmon, and now they're doing wonders. So in India also, we have genetics programs in salmon, and
Dr. Rameez, we lost your voice. Hello, Dr. Rameez. Hello. Hello.
yes,
Uh,
I hope I answered.
okay. There was a pause for a few seconds. I could not hear the last 1 minute.
Oh, last 1 minute. Oh, really?
Yeah.
No. Anyway, I said,
You about ICAR you are speaking about.
the ICR. I mean, ICR has 4 deemed universities. You heard that, isn't it?
Yeah, yeah.
Yeah, and I studied at ICR Central Institute of Fisheries Education, which is in Mumbai, and I did my master's and PhD in fish genetics and breeding. And later, I got really interested seeing the opportunities of the work that I can do in the field, and then I pursued it. I did get some opportunities to work in industries, but I did not go for that. Then I wanted to be in academics. So
Okay.
yeah, that's it.
Okay. Okay. So
Thank you.
yeah,
What else? Any other questions?
1 second. Yeah. No, I don't see any more questions. So
Yeah.
we have come to end of question round. On behalf of agricultureinformation.com, we like to thank you for the detailed presentation and answering all the questions. And we also like to thank all the participants for joining this meeting. The meeting will now be closed. Have a good and safe weekend.
Thank you.
Thank you.